All right, guys, we are doing our second lesson on exponents. It is a power to a power, which means I have an exponent on top of another exponent, and negative exponents. So I'm going to show you how to do those. It's a little more complicated than the last one, but the same ideas apply, and we're going to look for some rules that we can use every time. So our essential question, we have two since there's two different topics. How can we use expanded form when applying the properties for raising powers and products to a power? Again, we call that a power to a power. So there's going to be two exponents there. What happens when we have negative exponents is our second one. So our vocabulary is the same for the first part. Remember, exponent is the small number right here, and the base is the small number or the large number or the variable right here. Remember, expanded form was when I just write out what it looks like. Instead of 2 to the third, it really means I'm multiplying 2 times itself 3 times. Okay, so let's go ahead and look at these. Here is a power to a power, and that's what I mean. I have something that's being raised to a power or squared or cubed or whatever it is here. And then next to it, I have another exponent. So what this is telling me is that I should see negative 4 squared 3 times. Okay. Over here, this is telling me I should see 2n to the third 2 times. So I'm going to write these out in expanded form, and we're going to see what they look like. So negative 4 squared to the third, that means I have 3 of these. Negative 4 squared times negative 4 squared times negative 4 squared. Well, that's not completely expanded form because I still have exponents. So again, each of these can be expanded. Negative 4 times 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 negative 4, right? So when I look at this, again, I could multiply. A negative 4 times a negative 4 is a positive 16, and then I multiply that again times a negative 4, and that gives me, I don't know, like 54 or something like that, maybe. Anywho, I'm looking to put this back as an exponent. So it's telling me that I have 1, 2, 3, 4, 5, 6 negative 4s, and they're being multiplied. So it's really negative 4 to the 6th. Okay, so think about that and think about what rules we can use. And here's my second example. This is telling me I have 2 of these. So let's write that out. 2n to the third times 2n to the third. Okay, I still have exponents here, so let's write that out as well. This tells me I have 2 times n times n times n times 2 times n times n times n. Okay, so that looks like 2 times 2 because those are my like terms that I can combine, right? 2 times 2 is 4, or 2 squared. And n times n times n times n times n times n is n to the 6th. And since I can't do anything with that, it could be either one of those. Okay, so notice here my two examples. Spread those out for you. What do you notice about what's happening to the exponents? When I was multiplying and they had the same base, I added. When I was dividing and they had the same base, I subtracted. But now we have these two examples where I have a power to a power. So how do I get from 2 and 3 to 6? And these are both the same. I know that I multiply. So let's go back over here. And I'm going to write my rule. What is the rule? We can create, instead of using expanded form, when I have a power to a power, meaning I have two exponents right next to each other, I can multiply. So that just helps me to simplify, right? All right, let's look at what we have next. So here we have new vocabulary. We have a negative exponent, which means exactly what you see right here. instead of 2 to the third, I have 2 to the negative third. And so here's the rule for that. A negative exponent is asking us to use the reciprocal of the base. So if the base is in the numerator, I move it to the denominator. If it's in the denominator, I move it to the numerator. So instead of it being repeated multiplication for an exponent, a negative exponent is kind of like repeated division. Okay? We're going to look at some problems like that. And then the other thing that I want to point out is the exponent of 0. Any number or variable besides 0 to the 0 power is 1. Okay, and we're not going to have a ton of examples like this because they all would be the same. Again, anything in front here with a 0 exponent is going to be 1. Okay, so let's look at our negative exponent rule, and we're talking about reciprocals here. So I'm going to do a couple examples on that. Let's get this in focus. Okay, and when I see this, I have x to the negative 2. So remember what we said is I want the reciprocal of x then. So instead of it being on the top of a fraction, it's going to go on the bottom. Okay? Then I also have x to the negative 3. So again, I want the reciprocal of x, which the reciprocal would be, instead of x over 1, it would be 1 over x. So I'm going to switch this over here. X to the third goes on the bottom. Well, now I have nothing on top. So what do you think I should do? What do I put on the bottom if I don't have anything on the bottom? I put 1. Same thing with the top. Okay? So now I've moved my negative exponents, I've created them as positive exponents, but now I need to simplify this. So just like yesterday's lesson or the first lesson on this, when I am multiplying and they have the same base, I'm going to add the exponents because really it's saying x times x, so there's 2 of them, and x times x times x, so 3 more, so a total of 5x. So I'm going to leave 1 over x to the 5th. Okay? Let's look at the next example. And this one here, they're both negative exponents. So, excuse me, it's telling me I'm going to do the reciprocal of 3. Okay? So this says the reciprocal of 3. That means if I have a fraction, this is going to move down here. Okay? Moving it this way because the reciprocal of 3 is 1/3. So I'm going to put it here. I'll leave that right there. Now the reciprocal of this would be to send it on top. Okay? There we go. Now, remember when I'm dividing fractions and they have the same base, I can subtract because this is telling me right here that I have, excuse me, 5 of them divided by 3 of them, which gives me a total of 3 to the 4th. Okay. Now, finally, one more example where we have 3a. Nothing changes with that. Okay, there's no exponents. There's nothing I can do with it. So I'm going to leave it there. But a to the negative 3 says I need the reciprocal of that. That means I got to send it down so that it would be 1 over a to the third. But since I already have this up here in my numerator, I'm just going to move it with a to the third. Okay, so again, negative exponents tell me reciprocal, which means if it's in the numerator or if it's a whole number, I send it to the denominator. If it's in the denominator, I use the reciprocal and I throw it up to the numerator. Okay, what I see here is not simplified because I have an a on top and an a on bottom. So if you want to see it in expanded form, that's 3a on top, a times a on bottom. Well, this is like multiplying right here, correct? So one of these a's and that a can divide out just like we did on the previous. So I'm left with 3 times 1, and I'm left with a times a, or a squared. And there's nothing else I could do to simplify. Okay? So let's go back. This one doesn't necessarily have a rule that we can come up with because I already gave it to you in the vocabulary, But if I have a negative exponent, it's going to send that thing to the bottom in the denominator. If I have a negative exponent in the denominator, I bring it back up to the numerator. Okay, hopefully that makes a little bit of sense. Today has a review of both lessons in a Kahoot, so you'll take that. There is no time on it, so feel free to take your time, but make sure that you are working through the answers and that you're writing them down on your paper. And please come to us with any questions. Have a good day.